Hi everyone, today we'll talk about the thermoforming and blow molding. Now first let's look at the thermoforming. As you can see, we can use the thermoforming to make all sorts of products. Generally they are in the packaging field. What's thermoforming? Thermoforming is an important secondary shaping of plastic films and sheet. It consists of warming up your plastic and form it into a cavity or over to using vacuum, air pressure, and mechanical means. The new shape is retained when the material cools, and these are the two examples of thermoformed product. Alright, here is the process description. First of all, you want to heat up your plastic to uniform temperature, and then you will perform initial stretch using a plug for uniform thickness distribution. Then you will apply vacuum for final shaping. Once it's cooled, your product is removed. Okay, you can watch the two videos I put at the bottom to learn more about thermoforming. Alright, and sometimes we want to further reduce the film thickness. For this, we generally pre-stretch the sheet by forming a bubble like this. We heat it up and then we'll blow air into it and to reduce the film thickness before we apply vacuum and form the product. Alright, now let's talk about thermoforming materials. There are two groups of materials. The first one is amorphous material. Generally, we perform the process at temperatures slightly above their glass transition temperature. They are easier to work with because they have a wider rubber temperature range above TG. So we can shape them, but also when we are above the TG, the material still have enough rigidity to hold the heated sheet without much sagging. The other group is the semi-aqueous material. Generally, we set a temperature slightly below their melting point because once we are above their melting point, the crystalline structure gonna be breaking up, and then your material lose their strength very rapidly. Overall, it is easier to work with amorphous materials. Alright, now there are two types of thermoforming, thin gauge versus thick gauge. The main difference is in the thickness and the volume. Okay, for thinner gauge thermoforming, it is a more automated process, and we use sheet generally thinner than 0.0 to 6 inch, and they are continually delivered to the machine from rolls or from sheet extruders. It's primarily used for packaging material and high volume production. While thick gauge thermoforming using sheet a little bit thicker, they are thick about 0.3 inch, and they might be delivered manually. Okay, so and it's generally it is used to create sturdy and rigid enclosures. It is low volume runs. So if we could go back, these are two examples. This one is the product made from thick gauge, and this one is from thin gauge thermoforming. Alright, now there are different forming methods you could use. For example, straight vacuum forming and a plug assisted vacuum forming. They all use the vacuum. The third one is called a draping forming. So generally you heat up plastics and then you press the button forming into an oval mandrel or form, and sometimes using both the inside and outside form to create the desired shape without using of the vacuum. They all being used in the industry depending on the product. Alright, there are some certain defects for some formal product as well. The number one is a poor detail. You could also have a blister or bubbles such as shown in this picture. Now, if you heat your plastic too long, your product might be sticking to the mold, and that would result in a surface rupture, and also you might have excessive or post shrinkage problem. This is about the thermoforming. Next, I'm going to talk about the blow molding. Blow molding is used to produce hollow object that do not require homogeneous thickness distribution. The common materials used in this molding is high density polyethylene, such as used for milk bottle, or PET, that's for soft drink bottles. And there are three types of blow molding: extrusion, injection blow molding, and stretch blow molding. We'll first look at the extrusion blow molding. Alright, this is a setup for extrusion blow molding. You need to have an extruder, you need to have a cross-head die where you're going to extrude the tubes, which we call the parsley, and you need a clamping system, which is angle mold. This is the description of extrusion blow molding. You can read through. The first step is, first of all, extrude a tube or paraffin, right? And then you're gonna close. Once your paraffin reach the bottom of your mold, you're gonna close your mold. Then you're gonna blow the compressed air into the paraffin, and then the paraffin will be blown into the shape of your mold and being cooled. Then you open your mold, you should have your product. Again, this is a video you can watch to learn more about extrusion blow molding. Now, another very important component of extrusion blow molding is paraffin programming. Why do we need paraffin programming? It is for improve the quality, save material, and to reduce the cycle time. For example, in my hand I have this bottle, right? And you can see that on the top of the bottle where the material did not stretch that much compared to the bottom of this bottle. So in order to have a uniform wall thickness distribution of this bottle, the paraffin we start with need to have a varied thickness at the different positions. And we achieve this by moving the mandrel or bushing vertically during extrusion. Again, I strongly suggest you to watch the video, and very good. This is a very good video to show you the paraffin programming. Cycle time is also very important for extrusion blow molding. Most of the time, you will see industry using a rotating table to perform each these steps to reduce the cycle time. Alright, the next blow molding is called the injection blow molding. Well, for injection blow molding, first of all, you need a set of mold to make preform first. So this is the mold to make the preform, and you can see this after you cooled, you open the mold, you get this is the preform you get. And in fact, I have a preform right here, and you can see that this is a preform. Okay, this is the injection molded preforms. Then you can insert the preform to another set of mold, and then you heat them up, you blow air into it, and then to shape your product. After you cooled, you get your product out. The third one is called a stretch blow molding. The difference is generally the company gonna purchase the preform first, and they're gonna insert into the mold, and they're heating the mold, and also as well as to blow compressed air into it. At the same time, the cold pin moves, like stretch the preform. That's why it's called a stretch blow molding. Now you can see it from the shape of your mold. Once cooled, you get your product. Here is the summary of these three blow molding technologies. Extrusion blow molding offer a high rate of production with a low tooling cost, but there's always a higher scrub rate with a limited control over wall thickness. Injection blow molding has a higher production rate and with a low scrub rate. However, due to the need of two sets of mold, one for preform, the other one for your final product, injection molding has a higher setup cost, so it is least used blow molding technology in the industry. Instead, stretch blow molding has the ability to stretch the preform in both hoop and axial direction, so it is preferred over injection blow molding as it is more accurate and offers better overall qualities. Now, if you look at this bottle, you will see a line, right, coming off from the ceiling of the the paraffin. So when I look at it, I know this is the extreme bloated product. This one instead is a water bottle. If you look at the bottom, is you see a knob, and this tell me is either injection blow molded or stretch blow molded. Well, in fact, I think it's more stretch blow molded as the majority of the soft drink bottle I made. But hopefully you see the difference. All right, this is about thermoforming and blow molding. Bye.